Okay, now we're going to run a hypothesis test. We're going to do a two-sample z-test. We're going to compare two groups. In this case, we're comparing men and women in their preference, vanilla or chocolate. And we want to see if there's a difference between those two genders. And so we'll go ahead and recall how to run a hypothesis test. You got to define the parameters of interest, write the null and alternative hypothesis. And here we're saying that the proportion of men equals a proportion for women, or that there is no difference, right? Is there a difference? In green here is how StatCrunch writes theirs, and they use it by comparing a difference between them, right? Is there a difference? The difference between them. 0 means no difference, which means they're equal. Or the P, a proportion of men minus a proportion was not equal to 0, which means then that there is a difference. So just want to make sure you're careful of the notation as you look for other resources or look at other examples. You may see them written these two equivalent ways. We're going to use an alpha level of 5%. If it's not stated, that's kind of, again, back to a 95% confidence interval or a significance level of 5%. We go through the check, again, requirements. They're independent, independent. And so we see that test for independence here, these values we're assuming less than 5% of the population, right? Our sample sizes here. They were randomly selected, both groups, and are they large enough? Again, we look at the number of successes and oh no, we don't. Sorry. Oh yeah. Look at the number of successes and failures of the groups here. And so 27 men, 28 women preferred vanilla, right? So we're going to look at that proportion, and the failures, those who didn't, right? Those numbers are also, when you subtract them from the sample size, also greater than or equal to 10. And so now what we want to do is calculate a test statistic and a p-value. In the last lesson on hypothesis tests, we did it by hand. Here we're going to use technology to run two sample z-tests. Okay, and so let's go ahead and do the StatCrunch. It's similar to where we went in the last examples of running intervals. We're just going to choose the we're going to do two proportion stats, two sample. We have the summary data here, and notice we're going to run a hypothesis test here, and so we're saying that they are equal to 0 or not equal to 0, since we're trying to see is there a difference between them. And so we have the two groups. The men were first. That was our first group. Number of successes 27 out of 42. For women, we had 28 out of 54. And so the sample is different, but again, we're going to use that sample to estimate the population. And so that's why we run a hypothesis test. And that's it. We click that and then compute. And so you end up with a z statistic and a p-value. You end up with both of those there. Okay, now let's go ahead and look at the art of stat again. So we've been here before. We're two sample proportions. We're going to go ahead and do that. And so we need the summary statistics on this one here to enter that in. And again, we should get the same values. Number of successes, and we have our two groups. Our sample size for men was 42, and the successes for men was 27. This is 54, and this was 28. And so again, the samples, you can see the samples have some slightly different values. They're different, but again, doesn't mean the population. We're running a significance test now. It's two-sided because we were saying that it was not equal to each other, right? We were comparing both of those groups, and so then you can see here we have these values here, your test statistic and your p-value. And so that's what we have there. Okay, so let's go back to our notes. So you get a p-value, a test statistic of 1.22, a p-value of p-value of 0.22. Let's go back and check that real quick. P-value of 0.222, perfect. Let's get there, 0.222. And so then what we know, since the p-value, 0.22, is greater than the alpha, 0.05, we fail to reject the null hypothesis, right? So what that means is we're accepting this and we're saying that's not true. By accepting that, we're saying that there is no difference, right? We don't have sufficient evidence to conclude that there is a difference between those two proportions. And that's our hypothesis test like we did before, but now we have two samples and we're not doing the calculations by hand, we're using technology.